Bismillahirrahmanirrahim. Hello everybody. In this video I am going to brief you about a simulator that is called Opportunistic Network Environment Simulator 1 simulator, and this is the GUI of the one simulator. Um, if I click on this play button, we will see the simulation has started running. So basically what we are seeing is a map of a city, and then we are seeing some nodes that are moving on the road network of the map, and we can see that every node has a circle. Basically this circle is indicating the communication radius, and then we have this stack of colors. Basically this is the messages this node is carrying, and then we have two nodes with big size circles. So this represents the uh, long distance communication, or we can say like Wi-Fi communication, and these smaller circles represent the Bluetooth communication. So this is the simulator, and we can see these all the event log is showing what is actually happening. Connection is up between nodes and connection is down, message relaying. So every process is being shown in this event log, and at the right side of this we have these all type of nodes, in which P represents some pedestrian nodes. So these are pedestrian. Then we have some nodes that are vehicular. These are cars, so these are vehicles. Then we have another set of vehicular nodes, and then we have trams. So these are the trams which have the bigger communication radius, and we have all the information available that which node has what messages, and what are the source and destination of the messages. So this simulator is basically used to simulate the opportunistic network environment, and this is the paper that details this simulator. This is the one simulator for DTN protocol evaluation. So basically this simulator is used where we have delay tolerance in the communication. So we have delay tolerant networking. So this simulator is not useful if you want to simulate the mobile ad hoc network routing protocols, like we have OLSR or DSR, because the mobile ad hoc network routing protocols need the end-to-end connectivity. So this paper is this simulator is designed for those type of networks in which it is difficult to maintain an end-to-end communication path, and nodes are just exchanging messages as soon as they can get an opportunity to come into range of each other. So here's a quick overview of this simulator, and then in this video I will show you how we can download this simulator, and how we can compile it, install it, and how we can run a small simulation. So basically first a brief note about this one simulator. The one simulator offers an extensible simulation framework itself, supporting mobility and event generation, message exchange, delay tolerant network routing, and application protocols. A basic notion of energy consumption, visualization, and analysis, interfaces for importing and exporting mobility traces, events, and entire messages. So it is a very versatile simulator, and we can have a large number of mobility models. We can implement our own mobility models. We can provide it the external real-time real-world connection traces. We can also provide it the messages file, external traces, and all that. So what's more interesting about this simulator is that as we can see, it's a map of road network. So we can create our own maps using the OpenStreetMap API. So if we open it, openstreetmap.org, so we can see that we have this road network is showing, and from here we can download a portion of the map, and so for example manually select this area, and now I download this export, and I can see that this .osm file is now ready to download, and let's download this file. And we have this file downloaded here, and if I open it, we can see that this file is basically an XML file in which we have the latitude and longitudes of the map that are extracted from the OpenStreetMap. And then the one simulator does not directly accept this .osm file. We need to convert this map into the WKT file using a tool that is already available. So we have this website for the one simulator, and in this website we have different tools and all those things available in which we can convert the map to the WKT format and so on. So here we can see that this is the tool OSM to WKT. Using this we can convert the OpenStreet map to WKT format. How we get this page? When we write on Google the one simulator, this is the first page that is actually returned. So this is the page that I just showed you, and here it is mentioned that the one has moved to GitHub. See the new home page. Now if I click on this home page, and I can see that we have this one simulator ready for download. This is the version that is available for download, but I will suggest that you should not download this version because this is not gonna work. It is having some old configuration and setup, and it will not run with the modern versions of the Java. So it is better that we move to the GitHub page to get the latest version of one. And so basically this is the one that is the having the latest version, and we can see that there are still some updates being made to correct the errors. Now to begin installing this one simulator, we need a set of tools that should be pre-installed in our system, and now we go with those steps one by one, and so that we can configure this one simulator. So the first thing that we need to have in our system to run this simulator is we need to have the JDK or the Java runtime environment installed. So if I go to the command line, and if the Java runtime environment is not installed, if I write here Java C, so if I press enter, I can see there are some options that are being shown here. But if the Java C tool is not installed, then first of all I need to install that. And to install that, what I need to do is I need to go to the page from where that thing is available for download. So it is basically this is the path where the Java is available for download, and we can see that there are three options. So if I'm using the Windows, so I click on Windows, and from here I'm going to download this one, this x64 installer. So this is the file that I need to download. And how I actually got to this page, I need to write in the Google JDK download. So once I write this JDK download, then I am this is the first link that is being returned, and then we have this Windows, and then we can see that we have the same page opened. So this is how we are going to download the this file, and I need to run the setup. Once I download and install this file, and if I write here Java C, and if there is no error shown, then this means that the first step has been accomplished and the Java is installed. As a second step, I need to install Eclipse, because we want to configure the one simulator in the Eclipse as well. So for that I need to write here Eclipse, for example, download, and this is the first link available, and from here I need to click on this download x8664. So once I download this Eclipse, and uh, this file downloads when I download the JDK, and this file downloads, this one downloads when I download the Eclipse, and then I just need to run the setup of Eclipse, and I need to specify the workspace folder at the end. So uh, so once the path of the workspace folder is specified, the setup of the Eclipse is completed. So once we have these two items installed, now we can proceed to the next step, in which we are going to download and configure the one simulator using Eclipse. So to install and configure the one simulator in Eclipse, I first of all open the Eclipse IDE, and then I need to open the repository of this one simulator. We can see that this is the GitHub page of the one simulator. So what I need to do is I need to click on this green button, code, and then I need to copy this address, this github.com, and this address I need to copy it from here. So once I have copied this address, then I need to go to file. From file, I need to click on this import, and on clicking import, I need to select this git options. So basically we have this git option, and now once I clicked on this git option, there are three options showing. I will select the middle one, this projects from git with smart import, and click on next. And then out of these three options, I need to select this clone URI option, and then I click on next. And here what I need to do is I need to paste the path that I just copied from there. So here is the path that I I'm pasting. This is the path that I copied from the GitHub, and then I click on next. Then this is the list of items showing. From this, I just need to select this on master. This master I need to select, and then next. And then it is asking me the path of the directory where I need to place the one simulator that is going to download that is going to be downloaded from the GitHub. So for that, I select the directory. I have a directory named A, and then in this directory I have a folder named AAA. So this is the path I'm giving. So we can also browse it from here, and then I click on next. So it is downloading the files. And then I click on finish. So if we can see that here is a folder that is created here in my Eclipse, and we are seeing an error, error cross on this SRC. So to fix that, you just need to delete this test folder. This is not required in our case, so we just simply delete this test folder. Okay, and now that error is gone. Now next step, I need to run this. So I click on this start, right click on this one, and then I click on run as, and then click on this Java application. And then here I'm going to select this DTN sim core. OK, and here it goes. We can see that the simulator is running. It is loaded and it is running fine, and we can see that the simulation has started running. So all this configuration is basically controlled by a file that is present here. It's called default underscore settings, this file. So default underscore settings.txt file, and its details are available on in the papers of the authors that who developed this protocol. I just showed you a paper. All those details are there, as well as in the readme file you can find plenty of detail how to configure this default setting file. But just for a quick look, here we can see that this shows how much for how long the simulation should run. So this is like 200 seconds, like for 1 hour. And then we have, this is the scenario name, the name of the file that will be results file that will be generated. We can also substitute this with the arrays. All the information is available. And then we have this transmit speed, transmit range, number of host groups, how many groups are there. So we can have different groups of nodes having different types of nodes, and here are the individual properties of those groups defined. And this is the event generator settings, that what should be the frequency of messages that are going to be generated, and what should be the size of the messages. And this all information is about the mobility models. And we can see that different maps are actually assigned to the different nodes that are participating in the simulation. So it is very flexible simulator in terms of all these settings. And we can also simulate the UAVs using this simulator. We can also simulate the plane random walk. It's all controlled by this configuration file. We can run batch simulations, I mean, we are increasing the number of nodes on the x-axis, and for example, we are trying to see our performance using 50, 100, 150, 200, 250 nodes. So we can pass an array of nodes to this simulator, and it will generate a different result file for the different nodes. So it's very flexible simulator. And then we can also run this simulator in command line. So if I want to run this simulator in command line, I go to the directory where I have actually installed this simulator, cd d1. So this is the simulator, and the file name is 1.bat. But when I click the enter button, I'm getting an error here, because to run it using command line, I need to compile all the Java files in the simulator first. So for that, there is already a script available inside the simulator, and that is compile.bat. So I need to run this compile.bat. So we have this script successfully run, and we can see that all the files are compiled. We have just 13 warnings, but there is no error. And now I can write 1.bat to run the simulator, and see, we can see that simulator is running fine, and we are running it using the command line. And we can also run this simulator without the GUI option. For that, we need to write 1-b, and now this simulator is running without the GUI. So by this way, the simulation will be faster, and we will get the simulation results much quicker than in the case of GUI, because when we run it using GUI, the process slows up a bit. So let's wait a bit for the results to generate, and then I show you the result file. So all done, and so we have the results file created. And how to find that file, let me show you from where we can see the results file and what it shows actually. So let me show it in the Eclipse. So we open this the one simulator, and here we are going to open the, so I open this, and I let's refresh it. So once I refresh it, I can see that a new folder appear here with the name reports. So when I click on this folder, So this is the basically results file that is generated, and here we can see that it is telling us for how long this simulation has run, how many messages were created, how many messages started to relay out of this 59,000, how many messages were actually relayed, that are like 32,000, 27,000 were aborted, and 32,000 were dropped, and 374 messages were actually delivered. Delivery probability or percentage is 25%, overhead is 84%, latency is 4272, and median is 3205. So we have all this information available, and then this is basically another report that is generated that is, I think it is telling us that for how long the nodes remain in contact. So there are other some helper files that are available that we can use. So in example settings file, we have some protocol specific example setting files that we can use with different protocols, and we have a large range of protocols that are already implemented in this simulator. Similarly, we have some other files toolkit. In this toolkit, we have different I mean utilities that are there that we can use to create plots, or we can do some parsing, or all that, or we can create some mobility models. So this all toolkits that are already available here. And then the data folder contains the files of the road network that we are using, and we can see that there are different WKT files that are available, and basically these are the files that we get once we convert the OSM file into the WKT using the utility I just showed you. And then we have this WKT folder. Basically this folder is giving us some connectivity traces that we can give this simulator as an external file. So basically at this time connection is established, and message 1 is relayed between node 3 and to node 5, and this was the size of the message. So we have this connectivity trace file and the messages that are relayed, and we can see that there are different types of files, and for different nodes it is already available in this simulator that we can simply use. And finally I can show you the protocols that are already implemented in this simulator. So if we go to this SRC folder, and if I go to this routing folder, here are the name of the protocols that are already implemented, and we can see that this the active router is the parent class, and from this parent class these all base classes are derived. Direct delivery protocol, epidemic, Oracle, first contact, live router, maxprop, passive router, and so on. So these are all classes in Java that represent, each file represent a protocol, and they are already available, and we can see that this protocol has all this functionality defined is in this file, and we can develop our own protocols in this simulator by deriving from this active router class. So we can see that this protocol is also created by deriving this class from this parent active router class. Same is the case with the mobility models and so on. So here is our first video about the basics of this one simulator, and maybe in next few videos I may show some more simulation scenarios and some more experience with this simulator. Thank you for watching.